So hi, in today's lecture we are going to see how to remove the loop from the linked list. Okay, so in the last lecture you have learned the Floyd cycle detection algorithm, the Hare and Tortoise method. So over there we found out whether the cycle exists or not. But here's the real challenge. What if we need to actually break that cycle? So imagine that you are given a linked list with a loop and your job is to make a normal linear linked list again like this. So how you will be doing this? Now what if I tell you that the same algorithm that we use to detect a cycle can also remove the cycle? And here's the best part. You don't need any extra space. No array, no hash map, nothing. Just a clever pointer manipulation. So today I'm going to show you an elegant solution that builds directly on Floyd algorithm. And trust me, when you see why it works mathematically, your mind will be blown. So let's see the solution. Now before that, I need to tell you that actually I upload DSA lectures regularly to help you understand the concept in the easiest way possible. So if you find this video helpful, do like, share and subscribe. So now here is the example. Now the first step is that we need to apply the Floyd cycle detection algorithm, and I believe you know that. Over here we will be having two pointers, the fast pointer and the slow pointer. Now both of them will be pointing to the head first. Okay, now fast pointer will be moving two steps at a time, whereas slow pointer will be only moving one step at a time. Okay, now why we are doing this? For finding the meeting point inside the cycle. That means both slow pointer and the fast pointer should be pointing to the same address. Okay, so let's apply this. See, fast pointer will be moving two steps at a time and slow pointer is moving one step at a time. Let's do this again. Fast pointer is pointing to address 5 and slow pointer to the address 3. Fast pointer to the address 7 and slow pointer to address 4. Now fast pointer to address 9 and slow pointer to address 5. Fast pointer to address 5 and slow pointer to address 6. Now fast pointer is moving to address 7 and slow pointer is pointing to address 7. So over here we can see that both the pointers are pointing to the same location, right? So here we need to stop it. Now this meeting point holds a key to finding where this cycle begins. Okay, I'll tell you how. So the second step would be that we need to create a temporary variable that is pointing to the head only. Okay, now from here onwards I don't need any help of fast pointer. Okay, now here comes the synchronized walk. In a sense, temporary pointer will be moving one step at a time, so as slow pointer, and we need to keep going until you found temporary dot next is equals to slow pointer dot next. Okay, so let's do this. Temporary pointer is moving one step at a time, so as slow pointer. Let's do this again. This is pointing to address 3 and this is pointing to address 9. This is pointing to address 4 now, and slow pointer is pointing to address 10. Now here we can see that temp dot next is address 5 and slow pointer dot next is also address 5. Okay, so here we need to stop it. Now why we are stopping it? Because we can see that this is the starting point of the cycle. So if I break this link, okay, so obviously the cycle will be broken down. Okay, so hence we are stopping over here. Now now the question arises that how this is working. That means how the length of this is equal to the length of this, because the slow pointer was pointing here, okay, and the temporary was pointing here, right? So when I move one step at a time, the length of this is actually length of this, right? So I will be going to show you mathematically that how this is possible. But before that, I need to show you the pseudocode of this. Okay. So the first step would be that I need to apply the Floyd cycle detection algorithm. So the fast pointer will be pointing to head and the slow pointer will be also pointing to head, right? Now using the while loop in which fast pointer should not be equals to null and fast pointer dot next should also not be equals to null. We have seen this multiple times. Okay, now fast pointer will be moving two step at a time. So fast pointer dot next, whereas slow pointer is moving one step at a time. Now after doing this, if we found out that fast pointer is equals to slow pointer, okay, then we need to break from the loop because we found our meeting point. Okay, now as I told you, the second step would be that we need to create a temporary pointer, okay, that is pointing to the head only. Now here comes synchronized walk. Why? Because temporary pointer dot next should be equal to slow pointer dot next. Okay, so we can stop over there and we can just break the link. So while temporary dot next is not equals to slow pointer dot next. Okay, if they are not equal, then we need to be in the loop. So temp is equals to temp dot next and slow pointer is equals to slow pointer dot next. If we found out that temp dot next is equals to slow pointer dot next, then we need to terminate this loop. Okay, and after terminating, we just need to do one little thing, that is slow pointer dot next is equals to null. That means we have broken down the link. If we have broken down the link, that if we broken down this link, okay, so when I'm traversing, okay, so from address 10 I'm not able to go on address 5. That means I have the simple linear linked list again. Okay, so in this way you can remove the cycle from the linked list. Okay, now the thing arises that how this is happening, how the number of nodes before the starting point is equal to the number of node after the meeting point. Okay, see, I will be taking the same example. So over here we got to know the meeting point was address 7. So the fast pointer was pointing to address 7 and the slow pointer is also pointing to address 7. Now see, I will be having 4 variables. Okay, so here comes the first variable, which is x. X is nothing but the number of nodes, okay, from head to the entry point of the cycle. Okay, so I will be writing as distance from head to before starting point, sorry, before entry point of the cycle. Okay, and let's have a y, and y means from entry point of the cycle before meeting point. Okay, so y will be this part. Okay, so I will be writing y as distance from entry point of the cycle to before meeting point. Okay, now there is a c. The c is nothing but the length of the cycle. Okay, now I will be having two more variables. So let's say rf, which means number of rotation done by fast pointer, and I will be having rs as number of rotation done by slow pointer. Okay, these are the 5 variables. Now we know that the speed of the fast pointer is twice as speed of the slow pointer. Okay, so let me write this: speed of fast pointer is equals to twice of speed of slow pointer. Okay, so just keep this in mind because it will be very useful in the formula. Now let's find the distance covered by slow pointer and the fast pointer before meeting. So first let's see about slow pointer. The distance covered by slow pointer before meeting will be x, okay, plus number of rotation that it has done, okay, and plus y before meeting, right? So it will be x plus rs into c, because c is nothing but the length of the cycle, plus y. Okay, so sp will be for the slow pointer, the distance for slow pointer will be x plus rs into c plus y, and for the fast pointer as well, distance covered by fast pointer x plus r f into c plus y, right? The slow pointer didn't cover the whole cycle, right? So obviously the number of rotation, that means the number of rotation for rs will be 0, hence this whole value will be 0, hence x plus y. But if I take a look on the fast pointer, okay, the x will be 4, right? Now the fast pointer has completed its one round, okay, so 1 into 6. How 6? Because the length inside this cycle is 6, okay, so 4 plus 6 plus this 2, right? So it will be 12. Okay, so this is how I have calculated this. Now we know by the relativity formula that time is equals to distance upon speed. Okay, so I'll write this formula for fast pointer: df upon sf is equals to distance covered by slow pointer upon speed of slow pointer. Okay, now we know that the formula, right, this one. Okay, so I'll just substitute over here. So the formula for sf is twice of ss, so this will be df upon twice of ss is equals to ds upon ss. Okay, now if I calculate this, the formula will be df is equals to twice of ds, because this and this will get cancelled, right? Now I know the values of ds and df, right? So I'll just substitute it. So it will be x plus c into rotation done by the fast pointer plus y is equals to twice into x plus c into rotation done by slow pointer plus y. Okay, if I solve this, it will be 2x plus 2c rotation done by the slow pointer plus 2y, and this will be x plus c into rotation done by fast pointer plus y, right? Now I'll take this and this in the left hand side, so this will be rf minus 2rs. I'm taking c as common, and I will be shifting this x and y on the right hand side. Okay, so it will be 2x plus 2y minus x minus y, so this will become x plus y. Okay, and rf minus 2 r s into c. Now the thing is that according to the books, okay, the value of this will be 1. Okay, how this is 1, you can google it. So the value of this is 1, so due to this it becomes c equals to x plus y. Now if I want to find the value of x, it will be x is equals to y minus c. Okay, so due to that reason, okay, the value of x is equals to y minus c. Now what is y minus c? If I take this as a complete c, okay, and this is y, so obviously this will be y minus c, right? So due to that reason, x is equals to y minus c. So when I'm standing over here, okay, and if another variable is also standing over here, now if I traverse it one by one, obviously I will be meeting to the same location where it is starting. Okay, so in this way this algorithm is working. Okay, so I hope you got this. Even if you don't understand it, okay, you can watch it again and try to dry run it by yourself. Okay, now if I take a look on this time complexity over here, the time complexity for this is order of n, and the space complexity is obviously order of n. Okay, so I believe you got this. So if this lecture helped you understand the concept better, make sure you like the video, share it with others who are learning, and don't forget to subscribe for more easy DSA explanation. So that's it from my side. I'll see you in the next lecture. Till then, keep practicing.